This is exercise 28. It says some IQ tests are standardized to a normal model with a mean of 100 and standard deviation of 16. Part A says draw the model for these IQ scores. Clearly label it showing the 65, 95, 99.7 rule. And I've gone ahead and done that, and you can see I placed the center at 100. That's going to be the mean and the median of the normal distribution. And if we go out one standard deviation up, that takes us to 100 plus 16 to 116, and 100 minus 16 takes us down to 84. So within one standard deviation between 84 and 116, we have about 68%. If we go out two standard deviations, that takes us up to 132, and down 32 takes us down to 68. So between 68 and 132, we have 95% of the population. So 95% of the population have IQ scores between 68 and 132. And finally, if we go out three standard deviations, that takes us 3 times 16 is 48. So 48 above 100 is 148. And 48 below 100 is 52. And so we have 99.7% of the population between IQs of 52 and 148. And so yes, we do have a few people with IQ scores higher than 148 and a few people with IQ scores lower than 52, but they only account for 0.3%, or about 3 out of 1,000. Part B asks, in what interval would you expect the central 95% of IQ scores to be found? Okay, in this we're just going to use the approximate amount. So if we look up the actual z-scores and the exact values in the middle 95%, the numbers would be slightly different, but we're just going to use the 68, 95, 99, 7 rule to do this. And so the middle 95% goes from 68 to 132. So that middle interval will be 68 to 132, covers the middle 95% of IQ scores, okay? And again, this is an approximation. If we wanted to find the exact values, it would be off just by a tiny bit. C says, about what percent of people should have IQ scores above 116? So we want to know what percentage of people have IQ scores above 116. So here, I'm going to just redraw this, and we're at 100 here. And so by the 68-95 rule, 95-99-7 rule, we know that the middle part covers 68%, all right? And the normal distribution is perfectly symmetric, okay? Which means whatever portion is on this side is also going to be equal to the portion on this side. The entire curve adds up to 100%. So if I do 100% minus 68%, we have 32% left in the two sides. So if we have 68% in the middle, that means this side plus this side, the remaining parts, those add up to 32%. Okay, so 68 plus 32 adds up to 100%. So because the normal distribution is perfectly symmetric, we know that exactly half of 32% is going to be on this side, and exactly half of 32% is going to be on this side. So that means 16% is above and 16% is below. And again, these are all approximations. So about what percent of people should have IQ scores over 116? The answer to that is 16%. Okay, part D says, about what percent of people should have IQ scores between 68 and 84? And I'm going to just erase this for a little bit more room here. So between 68 and 84%, okay? So here, we go down to 84%. And over here, we're down to 68%, okay? And so again, 84%, between 84 and 116, and I'm going to write 132 over here. Again, between here and here, we've got 68%. and between here and here, that's 2 standard deviations. We have 95%. And we just saw in the previous part that for the 68%, this part over here, that's going to be 16%, and this part over here is also 16%. So here we have 16% in this portion of the tail, okay? And over here, so I'm going to just magnify this part, all right? And so this part goes up to 84%, and this is 68%. All right, and so we know this entire piece, the entire piece is 16%. And that's because we have 68 in the middle and 16% on each tails. Both of those tails add up to 32%. So we have 16 plus 68 plus 16. Those pieces add up to 100%. Okay? Now we have the middle 95%, which means if we got 95% in the middle, then this little triangle on this end and this little triangle on this end, those two pieces add up to 5%. These two add up to 5%. And because it's perfectly symmetric, half of it, 2.5% is on this side, and 2.5% is on this side. So we've got 2.5% in this little triangle, 2.5% in this little triangle, and 95% in the middle area here. And I hope you guys can see that. So on this diagram, that means this little triangle over here is 2.5%. So the remaining part right here is going to be 16%. This is 16% minus 2.5%. Or in other words, 13.5%. So 13.5% are between 68 and 84. And I hope that's okay, but clear to you guys. And if it's not, just study the diagram and ask yourself, if 95% is in the middle, how much is going to be in the parts on the tails, the remaining portion in the tails. And the last part asks about what percent of people should have IQ scores above 132. Okay, so this is actually, I think, easier than the last problem. But if we go out to 116, that's 1 standard deviation, and 132 is 2 standard deviations above. And again, if we go down 2 standard deviations above and 2 standard deviations below, this covers about 95%, which leaves a total of 5% in this triangle and this triangle combined. So we've got 95% in the middle, meaning a total of 5% in the remaining areas, being this tail and this tail. And so, because it's perfectly symmetric, if we just want to know one side of the tail, we take that remaining 5% and we divide by 2, and we have 2.5% in the upper tails. So 2.5% are above 132. Okay, and again, all of these are approximate. These are just approximations. The exact numbers are just off by a slight amount, but all of these are just asking for above and abouts, and these are based on the 68, 95, and 99.7 rule. And that's it for problem 28.